In this video, we are going to concentrate on how to write equations of lines. We have two formulas that we can use in order to write equations. We have the point slope formula, which is y minus y sub 1. Now, y sub 1, all this means is, hey, get the y out of your point. That's equal to the slope, which is little m, times, in parentheses, x minus x sub 1, which means the x from your point. So the point slope form of an equation, y minus y sub 1 equals the slope times x minus x sub 1. We can also use the slope-intercept form, which is y is equal to mx plus b. In order to use this form, I need to know the slope of the line, which is little m. I also need to know the y-intercept, which we will know as little b. So that's y is equal to mx plus b. If an equation's in slope-intercept form, I can instantly look at it and tell you the slope very quickly and tell you the y-intercept very quickly. This is a great way to graph. Now, both of these formulas, you need the slope, the little m. And so the formula for this slope of a line, the slope of a line, if I'm given 2 points, so if I have a point x, y, and I have another point, which is the x and the y. Well, this could be x sub 1 and y sub 1. That just means my first point. This could be x sub 2, y sub 2, which simply means the x and the y in my second point. So the slope is y minus the y over the x minus the x. Now just make sure if you pick the y from your second point minus the y from your first point, you need to do the same thing with the x's. X from the second point minus x from the first point. Really doesn't matter which point you use first. Now remember, for the slope, the y's are on the top. It's the y minus the y over the x minus the x. Okay, another point I want you to know is that vertical lines cut across the x-axis. They never touch the y-axis. So these cut across the x. So they're going to be x is equal to something. And vertical lines have no slope. Let's look at an example. Okay, if I have a line cutting across the x-axis, I should be able to know the equation of that line very quickly. Let's look at the points in this line. This is the point I went right to, but I did not go up or down. That's the point 2, 0. This is the point I'm going to go right to, and let's go up 3. That's the point 2, 3. Let's go right to and then go down 4. 1, 2, 3, 4. So this is the point I went right to and down 4. Do you notice something here? Every x on this line is 2. To get to any point on this line, I'm going to go right to, and I can go up, I can go down, I can stay at 0. But the x is going to be 2. This is a line. X is equal to 2. Well, let's say if I have a line over here, and let's say it cuts down through -4. Every x on this line is -4. I go left 4, then I may go up, I may go down, but the x is -4. This is a line, x is equal to -4. Do you notice these x lines, these vertical lines, they cut across x. They have nothing to do with y. But this is a common mistake. People want to think these are y-equal lines because they're vertical like the y-axis. They don't touch the y-axis. They cut across x. And all of these lines, all of these vertical lines, don't have a slope. No slope. If I was to work this out with my slope formula, the slope would be something like 8 over 0. We cannot have 0 in the denominator. That is undefined. So these have no slope. Now let's talk about horizontal lines. Okay, horizontal lines cut across the y-axis and they never touch the x. Let's think of some points on this line. This is the point 0, 3. I didn't go right or left. I just went up 3. This is the point. I went right 4 and I went up 3. This is the point -5, 3. What do you notice? All the y's are 3. This is a line, y is equal to 3. Once again, people get confused because it's horizontal, like the x-axis. This line never touches the x. This is the line, y is equal to 3. Now this does have a slope. The slope happens to be 0. There is a difference in 0 and no slope. It is a slope. It happens to be 0. A vertical line has no slope. So once again, there's a difference in 0 slope or a vertical line has no slope. Now, if you get really confused and you're taking a test and you're trying to figure out, so these y-equal lines, do they have a slope of 0 or no slope? Well, look at the line. Watch closely. Whoop, there it is. Horizontal lines, y-equal lines, they do have a slope. It just happens to be 0. Now let's erase that and let's look at this vertical line. If I get really confused on a test and I'm trying to think, oh, is that no slope or does it have a slope that happens to be 0? We see that vertical line. Watch closely, watch closely. This has no slope. Vertical lines have no slope. Horizontal lines has 0 slope. Okay, now that we know some preliminary information and formula on lines, let's work a few problems. Okay, in order to know what the slope of this line is, I should get it in slope-intercept form, which is y is equal to mx plus b. So I'm going to solve for y. So I will subtract x from both sides and add 15 to both sides. So on the left, I still have 3y. On the right, I'll have a negative x plus 15. I still have not gotten y by itself, so I will need to divide everything by 3. So y is going to equal, that will be negative 1/3 x, because there's just like a 1 in front of that x. 1 times x is x, plus 15 divided by 3 is 5. I have this equation in slope-intercept form, so instantly I know that negative 1/3 is multiply times x. That is the slope. The slope is negative 1/3. And if I wanted to know the y-intercept, where it crossed the y-axis, that is the little b, it would be 5. But what I wanted to know is, what is the slope of this line? My answer is, the slope of this line is equal to negative 1/3. Okay, let's try another problem. Find an equation of the line that satisfies the given conditions. So they tell us that our x-intercept is negative 8. Our y-intercept is 6. I need to write the equation of the line. Well, what are these points? What does the x-intercept mean? The x-intercept is negative 8. Well, if this is where it crosses the x-axis at negative 8, that is when y is 0. Okay, so let's look at this. Negative 8, 0. Here's the point, negative 8, 0. And sure enough, when it crosses the x-axis, For the x-intercept, the y is 0. Now for the y-intercept up here at 6, when it crosses the y-axis, that means this is the point, x is 0, when y is 6. So our y-intercept point, that means x is 0, and the y-intercept is 6. So I have my 2 points, and so now we can write an equation. We have 2 points. Now, do you want to use point slope, or we can use slope-intercept? It doesn't matter which one we start with. No matter what, though, I have to have the slope. So let's find the slope first. Remember the formula for slope? It is the y minus the y over the x minus the x. Does it matter which point we start with? No. But if I start with the second point and do the y minus this y, so that'd be 6 minus 0. So what I did is this y minus that y, and that will be over the x minus the other x. So that's going to be 0 minus, and this other x is a negative 8, so be careful here because this minus a negative will become a positive. My answer will be 6 over 8, that is a positive 8, that will reduce to 3/4. So the slope of this line that goes through those 2 points is 3/4. Okay, so I have the slope. So if we want to use the point slope form to write an equation, now it doesn't say point slope, just point slope. So I did need 2 points to get the slope. But now choose which point you want. I don't care, just choose which point, but don't use both of them. So if you want to use the negative 8, 0, and then the fact that that is a slope, let's get to work. Okay, so here we go. We have a point and a slope, and we have our point slope formula, which is y minus y sub 1 equals slope times, in parentheses, x minus x sub 1. So it will be y minus, the y sub 1 is the y from your point, which in this case, it is 0. That is equal to the slope times x minus the x from your point, which happens to be a negative 8. So be careful here because a minus and a negative become a positive. And y minus 0 is just y. And that'd be y is equal to 3/4 times, and that would be x plus 8. Now, depending on how your teacher prefers the answer, let's simplify this and then talk about the different forms. I'm going to use distributive property first. So I will have y is equal to 3/4 x plus 6. I use distributive property, 3/4 times x, and then 3/4 times 8. That's just 3/4 times 8 over 1. The 4 will cancel. That will go into that 1 time. 4 will go into 8 2 times. That's how I got 6. This answer, many teachers like it in this answer. This is slope-intercept form. Y is by itself. Sometimes they may want you to put it in standard form or general form. Standard form means I don't want any fractions, and I want my x and y's on the left, and I also want my x to be positive. I want it to look very pretty in standard form. General form wants everything on the left, even the constants. Well, let's get rid of these fractions. The common denominator is 4, so I will multiply the left side by 4, and I will multiply the right side by 4. Whatever you do to one side, you have to do to the other. On the left side, I will have 4y is equal to, use distributive property, the 4's cancel out. That'd be 3x, and 4 times 6 is 24. Okay, I don't have any fractions, but for standard form, I'm going to get my x over here on the left. So I will subtract 3x from both sides. So when it comes over here, that would be negative 3x plus 4y equal 24. Now, one little minor thing. We don't like our x to be negative. So I'm going to multiply everything by negative 1. What happens when you multiply both sides by negative 1? Negative 1 times a negative 3x. That will be a positive 3x. Negative 1 times 4y will be a negative 4y. Negative 1 times 24 is a negative 24. So now this is standard form. But some books even want it in general form. And these are all the same answers, just different forms. General form means get everything on the left. So I will add 24 to both sides. I will have 3x minus 4y plus 24 equals 0. So once again, this is general form. Standard form had my variables on the left and my constants on the right. That's standard form. And the first form we came up with was slope-intercept form, where my y was by itself. This way is much easier to graph because I know it crosses the y-intercept at 6, and then I will do the slope, 3 over 4, rise 3, run 4. So it depends on which way your teacher wants the answer. But all of these are the correct answer. Now let's do another problem. Okay, we want to write the equation of a line that goes through the point 1, negative 6, and I want it to be parallel to the line x plus 2y equals 6. Now remember, I need the slope. If I'm going to write an equation of a line, I need the slope. I don't have a slope. But what I do know is that it's parallel to this line. Now parallel lines have the same slope. Perpendicular lines have negative reciprocals. Okay, well, what's the slope of this line? X plus 2y equals 6. In order to find the slope of this line, I need to solve for y. So I will subtract x from both sides. Now remember, you can't put that x and 6 together. Those are not like terms. And now I'm going to divide everything by 2. So y is equal to negative 1/2 x plus 3. So the slope of this line is negative 1/2. And remember, my problem said I wanted to go through the point 1, negative 6, and I want it to be parallel to the line x plus 2y is equal to 6. I have just figured out that the slope of this line is negative 1/2. That's the work I did up here. I solved this equation for y. I found the slope. Now since I want my line to be parallel, I'm going to use the same slope. So now we're ready to find the equation of our line. So I have the point 1, negative 6, and I have the slope negative 1/2. So I have a point, I have a slope. I'm going to use the point slope form to write my equation. So it would be y minus the y from your point. So that happens to be a negative 6. That will equal the slope, which is negative 1/2, times x minus the x from your point, which is 1. And now I have to do a little algebra. Be careful, you have a minus a negative, so that will be y plus 6. Now I'm going to use distributive property. So that would be negative 1/2 x. Negative 1/2 times a negative 1 is a positive 1/2. Now there are a couple of different ways I could do this, but I don't really like fractions. So I'm going to go ahead and start by multiplying everything by 2, by the common denominator. Basically, you're multiplying this side by 2 and the right side by 2. Or you could just say I'm multiplying each term by 2. So I will have 2y plus 12 equals, and 2 times negative 1/2 x, the 2's cancel out. That's what I wanted. I will have negative 1x plus, once again, these 2's cancel out, plus 1. Now at this point, if you want it in slope-intercept form, get y by itself. If you want it in standard form, get your variables on the left. If you want it in general form, get everything on the left. So it depends on how the book requests your answers. This one, I'm going to put it in slope-intercept form. So I will solve for y. I'm going to subtract 12 from both sides. So I will have 2y equals negative 1x. and positive 1 and a negative 12 will be a negative 11. Divide everything by 2, y will equal negative 1/2 x minus 11 over 2. Okay, so this is our answer in slope-intercept form. We have solved for y. But if I go back at this point right here and want to get it into standard form, I'm going to slide that part of the equation back down here. And if I want it in standard form, I'm going to add 1x to both sides. So I will have x plus 2y. I would subtract 12 from both sides, and I would get negative 11. So that is in standard form. Of course, I could have brought the 1 over here. That would be x plus 2y. If I had subtracted 1, I would have had a positive 11 equals 0. And that is general form. So once again, you don't need to do it every way each time. You decide which way the book wants the answer. Do they want it in slope-intercept form? And this is how we would do it if we were typing it into a graphing calculator. Do they want it in standard form? That means your variables are on the left, constants on the right. Or do they want it in general form? Okay, we're going to do 2 more problems on lines. This particular problem wants us to write an equation of a line that goes through the point negative 1, negative 2. Ooh, and I want it to be perpendicular to this line. Where's my slope? I don't have a slope. Well, I know that if it's perpendicular to this line, find the slope of this line. Now, if it was parallel, we would use the same slope. But since it's perpendicular, I'm going to use the negative reciprocal. Now, I'm going to do this a little quickly, so you can stop the video and slow down if you'd like to. But I'm going to solve this equation for y so I can find the slope. So I solved this equation for y, and I found out that the slope of this line is negative 2/5. Remember, this problem said that they wanted it perpendicular, so I'm not going to use negative 2/5. So I have the point that it goes through negative 1, negative 2. That's my x and my y. And the slope of my line is going to be the negative reciprocal of this line. So instead of negative 2 over 5, it will be a positive 5 over 2. And now we're ready to get to work. So I will have y minus the y from my point, which happens to be a negative 2. That's going to equal the slope times x minus the x from my point. Let's do a little bit of simplifying. A minus a negative becomes a positive. Now, I could do a couple of things here. I could go ahead and multiply both sides by 2 in order to get rid of this fraction. Sometimes that will confuse people, so they want to do distributive property first. So that's what we will do. So I will have y plus 2, distributive property, 5 halves times x is 5 halves x, and 5 halves times 1 is just 5 halves. Let's put this one in slope-intercept form. Let's solve for y. I could get rid of the fractions first if that bothers you. Or if you're using your graphing calculator, I will just simply subtract 2 from both sides. I will have y is equal to 5 halves x. And 5 over 2 minus 2 over 1. You can use your calculator to help you out there. But that's the same thing as 4 over 2. So 5 halves minus 4 over 2 is 1 over 2. So this, I have written the equation of a line, and it happens to be in slope-intercept form. Okay, last problem for this video. I want to write an equation of a line that goes through the point negative 1, 2, and I want it to be parallel to the line x is equal to 5. Okay, you're going to have to use a little bit of common sense here. I see the equation of this line. This can be a very easy problem if you're thinking about it. I can't solve for y to find the slope because there's not a y. But think about this line. X is equal to 5. How does that look? Okay, x equals 5. That just cuts across the x-axis. That's a vertical line. X is equal to 5. It cuts across the x-axis at 5. X equal lines are all vertical lines. Well, if I want this line to be parallel to it, okay, this is the point -1, +2. It's about right there. And I know that it's a vertical line. This cuts across the x-axis at -1. The x here is -1. The equation of this line is simply x is equal to -1. Once again, I wanted it parallel to x is equal to 5, which is a vertical line. So that's an x equal line. So I'll look at my x and the point. So my line will be x is equal to -1 because it's going to go through the point -1, 2. There's that point. I wanted it parallel to this line, which happens to be a vertical line. So that's why I'm looking at the x. Okay, hopefully this video has helped you learn how to write equations of lines.